pre-algebra. We're already here. Roots, exponents, percentages, fractions. Man, let's go do this. First thing we're going to be working on is finding factors of a number. So to find the factors of a positive integer, we can iterate through all the numbers from 1 to any given number that we give. So we can do like define factors. Okay, so our factors variable is going to be factors equals set, and we're going to set this for I in range so every 1 times the plus 1 is gonna open up another if statement of we're gonna do x, get a percentage of I, and as long as it's not equal to 0, we're gonna add an additional factor. And then we'll do print, we'll do an f string here, the factors of x, which is the placement of our integer for the f string, are factors, which is our next f string. We're just going to grab this and stick it into here when we print it out. So now if we want to execute this code, all we have to do is do, let's say, a number, and then you do any number here. Let's do like 10, and then we'll do factors with number. Now if we hit play, then we get the factors are 10, and here it shows us all of the factors of the number 10. Now let's find multiples of a number. And for this we can make a function called multiples with using m as a variable for a count. And we'll do for I in range count. So for any integer within the range that we're going to specify, we'll do print I times m. And the way that we would use this is we would do multiples, and now we create a range. So we could do 10 to 5. And now if I run this, oh, I did a capital M by accident. So here it shows all the multiples of 10 5 times. So 1, 2, 3, 4, 5. We can also use the range with an offset by putting into our for loop a 0, and we'll do count times m and m. And if I run the same thing, now as you can see, we're adding a 0 to the end of each one. So that's what that 0 does. If I replace this with a 5 and run it, we can see that now we have that extra offset added into there. So our next one is going to be checking for prime numbers. And a prime number is a positive integer greater than 1 that has no other factors except for 1. So for example, 2, 3, 5, and 7 are prime numbers because they do not have any other factors. However, 6 is not a prime number. It is a composite because it can be expressed as, 2 plus 2 times 3. So we could do def prime num, and we could pass in a variable called num, and we'll do a Boolean operator here as false. Then we're going to do if the number variable is equal to 1, which could be a trigger for true and false. We'll do an f string here to pass in our num variable is not a prime number. And elif num greater than 1 for I in range to num. Now we're creating a range, and in that we're going to create an if statement where we're finding the percent of I, where we're going to do a divide with a modulo to check if there's any remainder. And if there is no remainder, then we can say that it is true. And then we'll break out of that loop. And if the flag is false, then we'll type is not a prime number. Else, if the flag is true, then it is a prime number. And the way that we would run this is we can do number equals, let's say 50. And we'll use this function that we created up here to pass in this number in the parentheses. And if I hit play, it's going to say 50 is not a prime number. And what about 7? 7 is a prime number. Now let's talk about linear equations. For linear equations, we're going to be using the NumPy library. And from that, we're going to be using numpy.linearalgebra.solve. And here it's giving you examples of the usage. So I'm going to come back in my file and do import numpy. And as you can see, this is not accessible. And that's because we should do python-m-venv to launch a virtual environment. And I'm going to launch my virtual environment in the folder of where I created this. So I'll do /venv. And we could do Control-Shift-P, where we can do Python select interpreter. We can go ahead and do enter interpreter and then click find. We're going to go under our V environment, scripts, and I'll grab this python.exe. Next, I'll look for the terminal, click on new. Once we've opened up that terminal, I'm going to go into the V environment, into scripts, and I want to activate and / type in that activate.ps1. Hit enter, and as you can see now, I've got this precursor before my text line that says V environment. And in here, I'm going to do pip install numpy. So now that we're all set up, I can hide this panel, and as you can see, numpy is now fully functioning and readable. And I'm going to give an alias to this as np for numpy. And in order to do linear equations, we can first define, we're going to be working with the coefficient matrix. So we'll do an A matrix, and then we're going to do a vector, which is B, maybe on the right hand side or something like that. And then we're going to do a solve. So this is a 3-step donkey. And the A equals a numpy array. So with this array, we'll do 4. We could put in the numbers of like a graph. I'm going to add another set of brackets, -2, -4, 5. These are just graphing numbers. And then we can add in another line. All right. So imagine these are just like points on a graph chart, right? Maybe it's a straight line, maybe it's a curved line, whatever it is. We're gonna now calculate the vector. So the vector is gonna be the array, and we're gonna input another graphing point for the vector. And then here we're gonna solve it by doing x equals np. And we're going to use that linear algebra solve, which runs an algorithm in numpy's library. And we'll do solution vector x, and then we'll just put the x in here. So instead of using the f string, we could do x like that, and then put in the f in the beginning too. If we want to make it an f string, that's fine. Keep it consistent. So if we were to run this here, and if we were to feed this into like a graphing software or something, then it could probably draw a line or something. And if we wanted to create an inversion for this, we would have to we could do A a inv for inversion equals np dot linear algebra dot inv for invert, and then we're gonna invert that a that we passed in earlier, and then we'll do a y. So y equals np dot a underscore inv, and we'll do a c for a new variable here, and we'll pass in this a invert variable, and we can create a new variable here for c as a placeholder. We pass in this b up here, and then we'll do print solution vector x using matrix inversion is, and we'll do the x variable here, put the f in the beginning, and now if I run this, it'll give us the standard vector equation and then the inversion equation. So now let's talk about plotting polynomials. For this one, we're going to be installing pip install matplot library. Now that we've got that installed, I'm going to import numpy again, and I'm going to import matplot library dot pyplot. Just like that. And the first one, we're going to be defining the poly coefficient. Now the coefficient, we're going to be doing this to create a variable here, which is going to return the length, and this is going to return a polynomial for a given value. For here, we're going to be giving the value of 0 for the length, and we'll do print f string. This is a polynomial of order O. And then the y is the coefficient that we're going to put into ascending order. So we could do like a 0, and then for I in range, we're going to make a range for that ascending order that comes with the polynomial coefficient. And then we'll do y plus equals, we're going to always add 1 every time we loop around the range. And then we'll do times, so this is an exponent, so we're going to do I times x, which is our coefficient, and we're going to do that, we're going to do it to the power of I. So that's our exponent. And then we're going to go ahead and return y. And in order to print these out, we can do x equals np dot linspace 0. You know, we could add in these variables. And we could do coefs to find the coefficients of these. So as you can see, each number is going to be pretty much represented as an x, which comes through the 0, 9, and 10. So each x is going to be represented by the numbers that I pass in here within the linear space. And then the coefs is going to be the o's. So O is our range that we're passing in to the O variable. And then with that, we can give this an alias up here as plot, and we'll do plot library dot plot, and we're going to do x and pass it through another variable for poly coefficient, which is already a pre-existing function within the matplot library. And then we can also add an x label. We can add a y label. We can add a title. Plot of the polynomial. And we can add a grid, type in true. And lastly, we can show our result. So if I run this here, you can see this is what our plot looks like. Oh, that's actually pretty cool. But we got a number 5 right here. How come we got that 5? So that's how to plot polynomials. And I also have a bug in here somewhere where it's putting 5 at the end of this print statement. And let's try this. Oh, and then it puts a 4 there. Okay. I don't know. I don't like it. So let's redo this because I don't like that bug. So instead we could do something like curve on the numpy array, and we can pass in just like the array numbers like 1, 2, 3, 4, 5. And then we can do the x, which is the x plot, numpy 0, 10. We'll do powers of 10 here. Dot linspace. So we're going to do a linear space here. And then we're going to do the y for the polynomial curve. So numpy dot polyvol curve, that for I and x. And then instead of this plot, we can just do x and y. The label I'll keep as x. The y label we'll do p and x again. We'll leave the title true, and let's go ahead and try to run this again. And as you can see, this time I'm not printing out anything, and I'm just getting this graph. And you can see now we've got it, the linear space all the way up to 12,000. So if I do one more here, let's do 1,000. Let's see what that returns. And that does the same thing. So now it looks like we were at 120,000. Next we'll talk about ratio and proportion. So here we could just define, like, a ratio ratio number or prop. There you go. Ratio proportion. And we'll just feed in one number as a float. So input, enter the first number. So we're kind of going back to, our arithmetic kind of style here. And do num2 float input, enter a second number. See what I did here? The first number I put in a single parentheses, second number a double. Yeah, okay. And I'm going to do an if statement. So if the number 2 is not equal to 0, then we're going to return a ratio of num1 divided by num2. And we'll do print, we'll do an f string. The ratio of num1 and num2 is ratio dot 2f. And then else, if the number 2 does equal 0, then it's going to error out because we cannot get a ratio or a proportion of two numbers that cancel each other out when they divide. The second number cannot be 0 because you cannot divide a number by 0. And in order to call this, we just go ratio proportion. Now if we run this, it's going to ask me to enter a first number, 10, and if I enter a second number, it says the second number cannot be 0. Alright, so we're printing out the second one. Our error works, so we'll do 10 and 4. So the ratio of 10 and 4 is 2.50. Now let's talk about exponents. You ever seen one of these before? So the way we can write this here is just 2 times 3. Another way we could do it is do 2 pow 2 to 3. How about one of these? For the second number, we could do 4 exponent 2, or we could do power 4 to 2. You ever seen one of these before? And this last one, we could do 10 to exponent of 16, or we could do power root 10 to 16. For the very last lesson, we'll be working right out of the Python terminal, and we'll do from fractions import all. And of course I'm doing this because I couldn't figure out how to import the fractions module. I tried to install it with pip, but it just wasn't working, and I just kind of wanted to get this video done with. So this is how you do a fraction. Let's do fraction 10 and 5. So a whole number and the half of that number. So here it's showing a 2 and a 1. So 10 to 5 can be simplified to 2 and 1. This is a half, as you know. So you could also assign this to, say, fraction 10 5 to an a, and then you could just do print a, and then here would show a 2. And now we could do another one like b. We could do an improper fraction and do something like 99 and 205, just random numbers, and then we do print b, and we can see that this is the fraction of that number. And if we were to do, we could do a minus b, we could do b plus a. We can also do more fractions like c. We could do fraction 2.5. And then we could print c out. And here we can see that fraction output representing this number. So that's all for my pre-algebra course. Thank you guys for watching.